All right, picking up from our last video, we finished up number 5. Let's move on to the remainder of the questions. The 6, 7, and 8 are going to be using Excel's functions to do some of the mathematics that we did manually before. So for number 6, it says use Excel's norm.dis to find the probability of number 5 above. I'm going to pull Excel over here. We're going to go up here to function, click on that, and it automatically populates here because I've used it. On your computer, it probably won't, so you'll have to type it in here. And then we're just going to enter our information. And so we know that our x value from number 5 was 7.5, and the mean was 8. The standard deviation was 0.4, and we do want a cumulative distribution, okay, because we want to find out the probability of getting a value up to 7.5 given a mean of 8 and a standard deviation of 0.4. We click on this. So it gives us 0.1056. Well, if you recall from the last video, that was the probability that we got when doing this manually. So double check that video and you'll see it's the same result. It's a little easier way of calculating the probabilities. Okay, let's move on to number 7. This one says use Excel's standardize function and the store data to create a column for store number 1 z-scores. So I've pulled my data here from the Blackboard link, and if you recall, we've used this data before. We've got shoppers and then the amount each shopper spent. Now we don't need store 2 and 3, so I'm going to go ahead and delete that. We're going to create a column for z-scores, and next to each of these shoppers and the amount they've spent, we're going to populate a standardize function. So click on standardize. The x value is actually going to be the cell that represents the dollar we're analyzing. So B2 would correspond to this cell. And then the mean we don't have. So we're going to put a placeholder here for that. Similarly, we don't have the standard deviation, so we'll put a placeholder there for that. Click on OK. Now notice it doesn't give us a z-score because we don't have the mean or the standard deviation. So I'm going to go ahead and populate those. And to do that, we go back to our function. Remember, mean is average, so we find the average of these values here. OK. So the average of these is 84.38, and then the standard deviation up here. And we're looking for standard deviation, so we'll put STD and always select the sample, stdev.s, sample, unless otherwise told. And from that, what we need to do is populate this. All right, so the standard deviation is 38.94. Now, when we go back now, you see our z-score. Okay? Z-score is 0.74. Well, that means that this number, 113.45, lies 0.74 standard deviations from the mean. Okay? But we want to do this for each of our shoppers. So we're going to drag this down. Now, I can tell you in advance, it's not going to work. And the reason it's not going to work, some of you probably recognize, is when I drag this down, I'm dragging down all of these boxes. But I don't want to drag down all these boxes. I only want to drag down B2. You know, I want the next number here to be, I'm sorry, fix that here. I want the next number here to be B3, right? And then B4 and then B5. But I don't want these to change because that's my mean and standard deviation. So I need to lock those. And to lock them, I just put a $ in front of the cells I want to lock. So I want the mean to stay at cell 22 and the standard deviation to stay at cell 23 as I pull this down. Now when I do this and then drag it down, it works. Okay, the next question is number 8, and it says use Excel's norm.s.dis to create a column for store number 1, cumulative probabilities. We'll work through this step by step. So let's go back to our data here. I'm going to create a column for cumulative probabilities. So cumulative probability, and we're going to select our formula, norm.s.dist. And notice the difference between these two. We just used this one, and now it's norm.s.dist. Okay. And for this, it's asking us for the z-scores. Well, perfect, because we actually have the z-scores. So we just put the z-score there. And then cumulative, well, we want cumulative, so we're going to put 1. Remember, the cumulative or non-cumulative is just an on or off switch. 1 is on, 0 is off. Click OK. And then we can drag this down. All right, easy enough there. I would encourage you to change these to percentages because they're a little easier to interpret. Now, once we've done that, it says sort the data by z-scores and create a histogram to illustrate the distribution. Okay, so let's take our data here and let's go ahead and go up here to sort, data, sort. We want to sort by z-scores, smallest to largest. Okay, and look what happens. So notice we go from negative z-scores all the way to positive. And notice our cumulative probabilities are going from low to high, which kind of makes sense because if you think about, say, this low z-score, negative 1.5, well, this is saying there's a 7% probability of getting a z-score up to that point. Another way of interpreting it is in x values, which would be there's a 7% probability of getting a purchase up to $25.79 based on your data. But if we go to, let's say here, a z-score of negative 0.2, there's a 42% probability of getting a z-score up to that value. There's a 42% probability of getting an x value up to 76.59. And as you continue on, you get to the highest z-score here. There's a 99% probability of getting a z-score up to that value. There's a 99% probability of getting an x value up to $178.36. So that's the way we interpret it. Now let's create that histogram. To do this, we're going to scroll over our data, and we're going to first create the histogram using z-scores. And so we scroll over z-score and then cumulative probability. And I'm going to do the same format, right? Select the first chart here, get rid of the unnecessary bars. So now we've got our cumulative distribution, and we know that we want no gaps, right? So we need to get rid of those gaps. Just double click on it, and now you got your histogram. Let's get rid of these redundancies. We don't need that. It says see probability, cumulative probabilities. Now you'll notice our axis here defaults to just 1, 2, 3, so on and so forth. What we want to do is go up here and select data and then define that x-axis there. The y-axis is fine, right? We want the cumulative probabilities. But if you want to change the horizontal axis, the x-axis, click on edit. And watch what happens. I'm going to first choose the z-scores as my x-axis. Okay. Now, notice it gives me all the way from the negative z-score, the probability of that occurring, all the way to the positives. So it sets it up in terms of z-scores. I could also do this in terms of my actual x value. So I could select this. That may be more appropriate if we were actually interpreting the data. Okay, so I click on that, and there's a cumulative probability of getting up to 25.79, cumulative probability of getting up to 88.90, so on and so forth. So that's how we create the histogram. All right, let's see what else we're asked to do here. Does the distribution change if you sort by dollars instead of z-scores? Notice that it did not. If we sort this by dollars, we get the same cumulative probabilities just as when we sorted it by z-scores. Go back and forth here. Notice that it doesn't change. All right, next we're going to calculate an x value for a given probability. Up to this point, we've really been going from x to z. That is, given an x value, our data, we've been converting it into a z value and then finding the probability of a particular z-score occurring. Now we're going to reverse that. We're going to be given the probability, we're going to derive the z-score, and then we're going to use that to find our x value. So working in reverse. There's two steps here. The first step is going to be to find the actual z value for whatever known probability you want to solve for, and then convert that z value into x units using this formula. So this formula says that an x value will be equal to the mean plus the z value times the standard deviation. Example, suppose x is normal with a mean of 8 and a standard deviation of 5. Well, we could find an x value so that only 20% of all values are below this x. Look at the information we've been given here. So we've been given the 20%, okay, which in our diagram here would be the bottom 20% of our distribution, right? Find the x value so that only 20% of all values are below this x. So whatever that x value is here, 20% would need to be below that. So we can shade that area in. So we've been given that. We've also been given the mean, so the x value, 8 is the mean, and we've been given the standard deviation. So in effect, we have a lot of this formula, right? We have 8 for the mean, we have 5 for the standard deviation. We don't have our z value yet, but we do know the known probability, so we're going to find that z value. To do that, we go to our z table. Now, this is where it can get a little bit hairy, because we're looking for a z value here that's going to be negative, right? When you go below a z value of 0, which is where the mean is, you've got a negative z value. And if you recall, the way our table is set up, it's set up for positive z values. Positive z values are reflected moving from the left tail to the right. So if we were looking at a positive z value, then we would be starting over here and moving this way. But because we're looking for a negative z value, we're actually going to start at the right tail and move this way, which means our distribution is going to tell us the value up to this point from the right tail. So it's going to be this area here, which is about 80%, right? Or it is 80%. But when you go to the table, you're not going to get that perfect 80%. You're going to get as close as you can, which would be 0.7995. Now, just to show you this, let me pull up the table again. This would be going to, let's see, 0.7995 right here. And notice that corresponds to a z value of 0.8 and 4. This is just an abbreviated table showing the same thing. All right, so now we have our z-score, which is going to be negative 0.84. Okay, so we would plug that in here, and I got it here. There we go, negative point. You can see it, negative 0.84. Then what we do is we find the z-score that, or the x value that corresponds to that z-score. And that's where we use our formula. So think about what we did. We just found the z value for the known probability, and now we're going to convert that z value into x units. So you're going to take the mean, which is 8, the z value, which is negative 0.84. You're going to take the standard deviation, which is 5, put all this together, and you'll get an x value of 3.8. That means that 20% of our x values will lie below 3.8. Okay, we'll leave it there for now and pick up with the next application in the next video. Thanks.